So today we're going to move on to chapter 3, ionic compounds. Hide floating neutrals. Okay, did anybody read a couple of sections of chapter 3 over the weekend? That's what I thought. Okay. I asked if y'all could. I think it helps. No worries. Okay. I might print some stuff out to read for tomorrow as well, but we'll be okay. You don't have to fill it out yet because I haven't started talking about it yet, but we will fill this out today. Okay, so again, chapter 3, you do have a textbook. So almost all the images come from the textbook, and we're going to slowly work on ions. Some of y'all have had some questions, and hopefully we'll cover it today and or Wednesday. Okay, so we're going to cover ions, how we name them, how they're formed, and eventually get into ionic bonds on Friday. So there's 4 learning objectives for this chapter. Does anybody want to read the first one?
Describe how ions are formed.
Okay, I'm not sure why y'all are all talking. Okay, one more time. Thank you.
Describe how ions are formed.
Awesome. Describe how ions are formed. The second one?
Distinguish the difference between the 2 types of ions.
Beautiful. Number 3?
Use the octet rule. Electron configuration to predict if an atom will gain or lose electrons from cations and anions.
Awesome. And number 4?
Describe ionization energy and electron affinity.
Awesome. So that's what we're going to go over today. Hopefully we'll get through all those 4 today. So one of the most common examples that you're familiar with is sodium chloride. This is a form of atoms that make ions. This is an example of atoms that form ions that together form an ionic bond. So is anybody familiar with sodium chloride? Do you know what that is? Another common name? Table salt. Yes. So salt, sodium chloride, those are one and the same. And so you can draw, this is one example you can draw. To show, you can, I would draw this out. So if we have sodium, we draw its, what are these kind of diagrams called? Bohr models. So how many electrons are in the first shell of sodium? 2. And how many are in the second shell? 8. And how many are in the third shell?
1.
Awesome. Okay, and then chlorine? How many are in its first shell? 2. And the second shell?
8.
1, 2, 3, 4, 5, 6, 7, 8. And the third shell?
7.
7. 1, 2, 3, 4, 5, 6, 7. Okay, so atoms like to have their outer shell full. So what is one way that both of these elements can have their outer shells full?
Sodium can give an electron to chlorine.
Sodium can give electron to chlorine. Beautiful. So if sodium gives one of its electrons to chlorine, sodium now has 1 more electron than proton. So what is its charge? -1. Awesome. And then because this went away, now sodium has 1 less electron than proton. What is its charge? Beautiful. Okay, so this Bohr structure can help you see. So now both of these have full outer valence shells. Sodium now has 8 and chlorine now has 8. The other way that could happen, chlorine could have given 7 to sodium, right? And that would have still given 8 and 8. But That sounds like pretty hard, right? Would you rather give 1 or you rather give 7? Which one seems more energetically favorable? 1. Okay, so chlorine could give 7 electrons to someone else, but that doesn't ever happen. I don't want to say like never, 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 ever, but like 1 in a million years that would happen. And we'll get to that by the end of the lecture, like why we know it's more energetically feasible to get for sodium to give 1 electron to chlorine. Okay, so if you don't want to draw out this Bohr model, we can use our electron dot structure. So sodium, the atom, has how many electrons in its outer shell? 1. Chlorine has how many in its outer shell, the atom? 7. So sodium can give 1 to make Na plus and Cl minus. Either one of these ways will help you figure out what atom is likely to give its electrons to the other atom. Okay, and so there we have a name for atoms that, or we have a name for ions that have a positive charge and ions that have a negative charge. Yeah, so cations have a positive charge. They have more protons than electrons. Anions have a negative charge and they have more electrons than protons. And so this was something from our homework yesterday. Let me go ahead and erase this one. So how many protons does sodium have? So sodium has 11 protons. If it gives up 1 electron, how many will it have? 10. And so 11 minus 10 is 1. So this is plus 1. This is how we know it's charged. It gave up 1 electron, so it has more protons than electrons, so it's positive. How many protons does chlorine have? 17, and it gained an electron, so how many does it have? What's 17 minus 18? Negative 1. Okay, so that, I know it's like boring math, but this is the math that we're going to be doing for the next couple days. Oh, sorry, my bad. Okay, any questions? And so anything with a positive charge is called a cation. Anything with a negative charge is called an anion. Cool, any questions so far? Awesome. Okay, here's one for you. So think about it for yourself and then we can discuss out loud. A calcium atom loses 2 electrons and a sulfur atom gains 2 electrons. Write the electron dot structure for each starting and then write the ion symbol. So this is like our ion symbol, Na plus 1 or Cl minus 1. And then which one is the cation and which one is the anion? So this is an electron dot structure. Of the atom with a neutral charge. And this is the ion symbol. Can you all see above the desk? Okay. So where's the sulfur? Oh, certain how many electrons are in the state? Two, one, two. You can look right here, calcium is in the second column.
Yeah.
Silver is in the sixth column.
All right, thank you.
So always has one. No man calcium gives you Yes. You're gonna get a question? Okay. Yeah.
Oh, and then,
And then,
CA,
submit it to you.
so CA had
So
no.
like this is just your, and you get like your yeah. How did
Minus. So I think it's.
Pretty much that, pretty much that.
Right. No, because one of the guys just calcium. Exactly. Minus.
I think I
know. Or is it?
And does,
No, it shouldn't be this one.
some of your medical papers, seen it, that you have discussion?
Yeah.
Okay, cool. Take care of yourself.
Okay, y'all wanna see the answer? Okay. Okay. Okay, so the Lewis dot structure is another word for electron dot structure. So calcium, it's in the second column, which means it has 2 electrons in its outer shell. in the fourth shell, which is its outer shell. So we draw calcium, we write the symbol and add 2 dots. Sulfur is in what column? The 1, 2, well, we skipped the D block. It's in the 1, 2, 3, 4, 5, 6th column. So it has 6 electrons in its valence shell. So we draw 6 dots. So this is the atom. These are both neutral. They have the same amount of protons and electrons. So again, calcium has 2 in its valence shell. Sulfur has 6. If calcium gives its 2 electrons to sulfur, what is its charge? +2, and sulfur's charge? Awesome. So now sulfur has 8 electrons in its outer shell, and calcium also has 8 electrons in its outer shell, the one less. Cool. Any questions about that?
The charges cancel out.
The charges definitely, they cancel out, yes. So if they didn't cancel out, so for instance, if this was sodium, sodium only has 1 electron to give. So sodium would become +1 and sulfur would be -1. But it wouldn't quite have a whole electron. It wouldn't quite be full, so it'd want like 1 more electron from some other element. Which we will get into that on Friday. Yes.
I really get it. Why would they also charge?
Okay, so how many protons does calcium have? 20. If it gives away 2 electrons, how many electrons does it have? 18. What is 20 minus 18? +2. Yeah. Okay, so the same thing for sulfur. How many protons does sulfur have? 16. If it gains 2 electrons, how many electrons does it have? 18. What is 16 minus 18? -2. Yeah, now we get it. Okay. Okay, so we on Wednesday, y'all are gonna practice this. Okay, with gizmos on Wednesday, you get to play around and like see all the orientations. But what I would like for you to do now is to fill out this upper table if you haven't already. So again, you look at the column. So how many, this column right here, this very first column, how many electrons can it give away? 1. The second column, how many electrons can it give away? 2. The third column, how many electrons can it give away? 3. This fourth column, it has 4 valence electrons. It could go either or, but actually it doesn't normally. It forms a different kind of bond that we will talk about in 2 weeks. So that's why there aren't any in the fourth column on your little sheet. Okay. How many electrons are in this column, in the outer shell? 5. Do you think it wants to give away 5 or take 3? This one's gonna take how many? 2, 1, 0. It's already ready. Like these don't want to ever form an ion bond because they're already full. They're like, I don't have space for any more electrons. Cool. So does that make sense to fill out that top table now? Awesome. Yes. Yes, it would gain 3 electrons.
No, what do you mean? It would be gain 2 electrons.
So put a,
Oh, no, it's just like.
okay, yeah.
Yes, because it's given. No, why do you put blue? Oh, yeah. You put blue too, so.
Like this one, it's got like 2 electrons to get rid of, so getting rid of like that first one. It's like a 2-step process. You can call it, I think that's my understanding, I'm gonna look that up for you, but I think they can form, it's like a 2-step process, getting away one electron and with.
Because like, why is not good
Yeah, so like, so these are more like available, we'll talk about that. But yeah, you can have, and also these, one of the reasons why these are called beneficial cells is they can be like +2 or +3. So it's like your original cells to be able to get rid of. Yeah, so you could delete the first. Just read it as what is yeah, so. That was I could have said, okay, so if you so the right side, what's easier to get to 8? Is it easier to give away 7? Is it easier to like give away 7 or is it easier to give away 1? So if it's on the left side, it's more likely to give electrons. The right side is more likely to receive electrons. Okay, so like gain electrons. Yes. Yes. Okay, so if they're giving away electrons, they have more protons, electrons. If they're gaining electrons, it's just the outer shell. Ignore all the okay, sorry. We're gonna cover. So row 3, how many electrons? 1, 2, 3. So it's going to give away 3 of those. Correct.
Wait, balance electrons.
It wants to have a full outer shell. So, yeah, it wants to have 8 in the outer shell. So if it has more than 4, it's going to gain. And then if it has less than 4, it's going to give 4. So it's nice to have So this is like so what happens is actually if you come here to here, this has 2 electrons in the outer shell and 9 right. So these go inside. Oh no, I mean overall.
I need.
Let's take the one. The last two, so it's the project.
What about offset?
It's got 6 Okay.
Dude, the rock.
What happened to the rock?
No way.
There should be.
Frustrated. Oh, I probably done it right Nice. This one is gonna, it gains 2 electrons. What is the charge? So it gains 2 electrons. So here, there's 2 columns. Okay, so this column is like a text. And this is text. So. I probably should get some answers. What's that? Yeah. So see, it gains, so loses 2 electrons. So its symbol B minus 2.
Yo, that's a this. I don't want a 5-5-40. Sales, I don't want a 5-5-40. Yo,
Yeah.
it's not a problem.
I wasn't looking at my hand.
Y'all got something to say? Say it.
Somewhere else.
Alright, I mean.
No, it's November.
Oh, it's okay.
It's the Monday before
I guess
Just this one.
Oh, good, well, see, that's what
Next Wednesday.
It'll be like your homework and you're on Friday? We'll have a review day.
Oh, okay.
Not your 6.
I have to go to the press about that.
Fine.
Yes. I'd like to write it down. It's like, but yeah. But that's great. Yes. I would like write it so you're not so confused with like. Why?
Only logical.
I'd like to know. I've had another couple of How long has it been?
Like mine are half the weight, like I'm so like the most I have is like the best. That's like most I have is like I know, so look, I'm gonna do something about that.
I think.
I really think it's A. I think it's B. I think it's A.
Okay, so I put a couple answers up here. Okay, so this isn't the whole table, it's just part of the table. So the valence electron, it's just the outer shell. So it's ignoring, so if something's in like the fourth row, it's only looking at the electrons in that outer shell, in that fourth shell. You're ignoring all the electrons in shells 1, 2, and 3. So beryllium has 2 valence electrons because it's in the second column. So one rule that some of y'all have seen, if it has less than 4 valence electrons, it's going to give them away and become positive. Which makes it, what kind of ions are positive? Cations. If it has more than 4 valence electrons, it's going to take them. And when something has more electrons than protons, what is that? An anion. Okay. So everyone can see how beryllium has 2 valence electrons? It's in the second column. So if it gives those 2 away, it's going to become positive. Question? That's what, it's pretty rare. In 1 week, we'll talk about covalent bonds. They do form bonds. So you remember when we played with that, we'll bust out our chemical set. Carbon it's missing 4. It's kind of like, it could give away 4. It could take 4, but more often carbon doesn't form. Carbon likes to share electrons, which we'll get into that in a week. So hold on to that question. So the answer is like, we don't normally see like a +4 or a -4 from that middle column. They do form bonds, but they rarely are, they prefer to share electrons than to give them away. Awesome. So nitrogen, it's not going to give away 5 electrons. It's going to take 3 and become negative. Okay, so does that make sense? Everybody see how you count how many valence electrons you get, and then how you make an ion. Awesome. Okay. So like I said, on Wednesday, we'll do a gizmos, and you can play around with, and it'll tell you the right answer. It'll be like, if you choose the wrong giveaway or take, it'll be like incorrect, try again. Okay. So this octet rule, what does oct stand for? 8. So this octet rule, it's a lot to read. How can you predict the number of electrons lost or gained? The atoms, they want 8 electrons in their outer shell. So that's how we're ignoring all the inner shells, and we just focus on the outer shell. It wants to have 8. If it has less than 4 electrons in the valence shell, it's going to give them away. More than 4 electrons, it will accept. So they both have 8. Okay. And so if we've been using this dot structure, but we learned how there's a lot of electron configurations in this chapter. We've learned how to write it out. So if sodium, this is its electron configuration, 1s2. So in the 1s shell, it has 2 electrons. In the 2s shell, it has 2 electrons. The 2p shell, it has 6. And the 3s1, it has 1 electron. So it wants to get rid of this 3s1 electron and become 1s2, 2s2, 2p6. So what element has this configuration? 1s2, 2s2, 2p6. You can either look at your periodic table that I gave you last week, or you can look at the periodic table up there on the wall. Neon. So electrons, they want their electron configuration to look like elements in that last column. That's that octet rule. So you can either remember they want 8 electrons in their valence shell, or you can remember they want to have the electron configuration of a noble gas. So same thing for chlorine. Instead of giving away 7, it's going to accept 1. And what element has electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6? Argon. Beautiful. So it's not turning into argon, it's just having an electron configuration that looks like argon. It still has a different number of protons. Cool, does that make sense? Do you want to do one more practice, or are you good with the table? Okay. So, if you're ever confused, I made you figure it out the hard way, but the answer, like I said, usually these answers are out there. So this is figure 3.3 in your textbook, and it tells you the answers, so you can go back and check your work later. So what is everything in the 1A column, or the first column, what is its charge? +1. Everything in the second column, what ions does it like to form? +2. We jump all the way over here, we've got aluminum, +3, nitrogen, -3, oxygen, chlorine. Okay, cool. What do we notice about, so these are our transition metals. What do we notice about them? They've got multiple charges. So because if you remember, we're going to talk about this some more. So all of these elements in the D block, they have 2 so if we look at this first row, scandium, titanium, chromium, everyone in the 3D block, they have 2 electrons in their valence shell and more than 8 in their third shell. So we put 4s2 within like 3d1, 3d2, 3d3. And so it can kind of move some around. Usually you would think it has 2 electrons in its valence shell, but it can send some electrons from its D shell to the S shell to be able to give away more electrons. So electrons can kind of move a little bit, because they can have like 3 in their S shell, or they can have 2 in their S shell, kind of if they move electrons around. So like gold can have +1 or +3, silver can have +1, copper +1 or +2. So they're able to move their electrons a little bit to make more than 1 ion. But this is a table in your book that you can look up. So if you're ever doing your homework and it asks you, what is the element likely to form? You can look it up in this table. Cool? So you don't have to like guess for memory and maybe get it wrong. Look it up in the table. So if it's telling you that Mg2+ is a likely ion, well, there's one question that asks, do you think Mg+1 is likely to form or not? No. If it were, it would be written in there. So it's like the single plus is like synonymous with the +1. Does that make sense? Cool. So the first question, number 2, K+ is definitely likely to form. Mg2+ is definitely likely to form. Mg+1 not likely to form. So what about question 3? Is sulfur -3 or nitrogen -3 more likely to form? Nitrogen -3. Sulfur, what ion would sulfur form? -2. Cool, does that make sense? Awesome. And so this, especially for the S and the P block, it's very predictable based on their column. The transition metals, they've got multiple options. And we'll talk about their names Friday. Likely or not likely? I think I switched. The book has not likely. I wrote down likely on the quiz. Magnesium plus is unlikely to form. K plus is likely to form. Got it. Sorry, I shouldn't have switched. I shouldn't have switched it on the fly. Oh, your textbook asks the, yes. Oh, wait, one more, wait, 10 minutes, and then we'll get to that question. Yes. We're getting there. We're getting there. I knew, so I debated giving y'all that handout at the beginning. I like to work ahead. It's all good though. Okay. Any questions about common ions? Awesome. Okay, so electron affinity. Does anybody know what the word affinity means? We got, our teacher knows. Anybody have any idea what affinity means?
I have an affinity for Cheez-Its.
Oh, so what does
I
that
have an
mean?
affinity for beautiful sunsets.
Yeah.
What do you think it means?
We wanted, it's like an attraction, a desire. Yeah. Electron affinity. So this graph, there's sort of two parts to this graph. Electron affinity talks about an element's want of more electrons. So, okay, so if everything with less than 4 elements likes to give away electrons, do you think it has a high affinity or a low affinity for electrons?
Low affinity.
Low affinity, beautiful. If everything that has more than 4 in its valence shell likes to take electrons from something else, what does that mean? Has a high affinity. So this graph is in your textbook. The elements with the highest electron affinity come from the FCl bromium iodine column. Fluorine, chlorine, bromine, iodine. We got gold and something else. So elements with 7 electrons in its valence shell, they really just want 1 more electron. And they are going to steal it from anything that they can that comes nearby that has a low affinity. Everything on the bottom, these are our noble gases. So helium, neon, argon, krypton, all these things that already have a full electron valence shell, they're like, no thanks, I'm good. They have an incredibly low affinity, which means that they're incredibly unlikely to take electrons from someone else and form an ion. The other way you can read that, okay, so the other way you can read that, it's, we've got this like, it's called like a Manhattan plot, because it looks like skyscrapers in Manhattan. So the very last column is almost impossible to see, but the noble gases have 0 electron affinity almost, or approaching 0. Elements in that second to last column have the highest electron affinity, and it kind of, so this is the last column, fluorine, oxygen, nitrogen, and carbon. So see how carbon has like, it's kind of this little bump in the middle. It doesn't really have, it likes electrons. Over here, these have a pretty low electron affinity. They like to give theirs away. So these two graphs show the same information. One of them is plotted on an X and a Y axis, like a graph. The other one, the data is put on a periodic table. So you understand how to read both of these? Like the higher the electron affinity, the more likely they're going to take electrons and become a negative ion. Any questions about those two plots? Okay, so a similar concept is ionization. So ionization energy is the amount of energy required to either gain or lose electrons to become an ion. So cations like to lose electrons, anions like to gain electrons. This is telling you how much energy is required to make an ion. And so this increases across the right. There's lots of energy required to either give or take away electrons. But notice which column has the highest ionization energy? The far right. So that far right, it takes an incredible amount of energy to make an ion. Doesn't mean it will never happen, it just means pretty unlikely. Which one has like the lowest? excluding hydrogen and helium, which one has the lowest ionization energy? The first column. So do you remember your flame test? What were some of the salts that you used to form the flame test? Are they from that first column? Some of them were the first column, where were some of the others from? You had lithium chloride, sodium chloride, potassium chloride. That first column really likes to give away their electron. And so it takes low energy to give that electron away. How's it going?
Good.
You looking for someone? Which one?
He isn't the library.
Oh, no. Thank you for letting us know.
If he comes back, he has a ball.
Okay.
That's me, but it's the front.
The other Elijah?
Yeah.
You're funny.
Oh, the other line. No, the there, yeah. There you go.
Oh, what are you
You're
telling
welcome.
there? Thank you.
Woo!
Oh, look, you gave it. You had a high affinity for that.
Yes, had a high affinity for that electron.
Whoever sold this must have been like that.
Okay, so what does electron affinity refer to? The attraction of electrons. And what does ionization energy refer to? Exactly. Oh, okay. Wow, we got through a little bit more fast than I wanted. That's okay. Okay, so we have one question that has to do with that. So let me go back and I'll put this one on here. Okay, so work on that last question.
No, it's ionization.
It is ionization energy, not electron affinity. Okay. So this chart right here, they're all kind of colored. So if it's a purple dot, I don't know if you can see color or not. Maybe the purple dots are the S block. The green dots are from the P block on the far right. Red is the D block. So you can kind of read this graph, or you can read this graph to order them by ionization energy.
Yes.
Yeah, it's so is the reason.
Actually, no. Ionization
So the reason by chapter, so it loses an electron, it has one pure electron, so it's plus charge. So it gains electrons, one more electron. It's like it is a little bit back. It is a little bit. Yeah, that makes sense. Yeah, I would love it. You got it?
Oh my goodness.
Okay. I might be wrong. I probably am wrong. No.
I'll play it. Yeah, I don't know.
Yeah.
Just 'cause like I can't really focus.
I already
And
said
then
it.
Yeah. Oh my God, you can't.
All right. Oh. Or like, she has extra.
Yes.
Ionization.
Electron affinity problem. Yes.
So,
With this graph here. So this one is the ionization energy. Actually, you're right. It does also follow that. Yes. 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 Yeah, you're welcome.
What else is AS?
It's in the nitrogen solids. Arsenic.
Oh, okay.
Oh, it's this one right here. So it's gonna increase the farther right you go. So what's the farthest right element? AS is the farthest right. Yes. Like it goes right there. Yeah. Oh, right.
Well, you guys are done. Yeah. How'd you get me? Left to right.
Okay. I think we can probably sit down.
Yes, you can understand.
Any questions?
Oh, yeah.
Okay, I've got more stuff. Okay, thank you. Okay, y'all ready to see a funny video? Hopefully this will work. I hope it doesn't log me out of TikTok. They might not let me. Does it not allow TikTok on my school Wi-Fi? Yeah. I don't know how to. It doesn't like it. Refresh. Okay, I'll post a TikTok that goes over what we did today, which is like some rap guys singing about Ionic bonds versus me. Okay. Okay, in the meantime.
We're gonna be doing the lab on Thursday, or we're gonna do it Wednesday?
So on Wednesday, it'll be kind of the same. We're gonna do a little pre-lab. So on Wednesday, we're gonna do one gizmos together. There'll be like a little handout that you fill out. And then, so I'll make sure like everybody's got their gizmos working and you'll kind of understand like how to navigate them. I think you'll have all done one gizmos before, right? No, yes, no. But so on Wednesday, we'll do a pre-lab, one gizmos, and then on Thursday, you'll have 2 gizmos to do. And then I'll have one bonus one if anybody wants a bonus one.
So I have these guys tomorrow, right?
Yes, you have them tomorrow.
That's-
You got your thing. Yeah.
Can I say something about that?
Yeah, I think I have.
Wait, you don't, I'm not gonna interrupt you. 5:20, right? Or 2:10, I think.
2:10, I've got 10 minutes. Okay, good. Okay, so a little precursor for what we're gonna do on Friday. So Friday, we're gonna continue our lecture. So what is the, we talked about NaCl earlier. How do we say that out loud? Sodium chloride. So what is Cl on the periodic table? Chlorine. So, and your next homework, I'm not gonna give you until Tuesday. We're gonna go over all these things have names. So fluorine is an element. What is the name of F-1? Fluoride. Chlorine is the element.
Fluoride.
Chloride. So these all have an "ide" in them. So if you hear nitride, fluoride, chloride, that's an element. Sorry, that's an ion. If you hear fluorine, chlorine, bromine, those are atoms with a neutral charge. And then, if you remember that periodic table,
Oh, yes, add the ions.
yeah, so we've got, it gets a little different though, because we've got 1, 2, 3, multiple options. So it's chromous and chromic, ferrous and ferric. So on next Tuesday, you'll get some homework where you practice writing all these out, so you'll become familiar. So when you hear chloride, you'll know what that means. When you hear ferrous, you'll know what that means. Okay, yes. Any questions about what we went over today? Yay, thank you so much. And we'll let Ms. Riggs take it away.
Okay, my friends, can everybody look up here for a minute, please? Eyes front, please. Fellows in the back, can I have your eyes up here? Okay, thank you. I want you all to get out your phone